Welcome to Lesson 2, Calculating Heat. Our lesson objectives: calculate heat, specific heat, mass, and change in temperature of a reaction. When we calculate heat of a reaction, our symbol for heat is going to be Q, and it can be measured in either joules or kilojoules, which is related to the calorie. If the Q, the heat, is positive, the reaction overall is endothermic, taking in energy, and if the Q is negative, the reaction overall is exothermic, meaning releasing energy. Our Q, our heat of the reaction, is based upon how much of the substance, so the mass of the substance that we have, the change in temperature that it undergoes, and the specific heat of that substance. So what is the specific heat? That's the amount of heat energy that's needed to raise the temperature of 1 gram of that substance just 1 degree Celsius. And so here's a list of some common specific heat values for some common materials. On the bottom we have iron, copper, and lead. So these are metals, and we can see metals have a very low specific heat, meaning it doesn't take a lot of heat energy to raise their temperature, or in turn the other way, it doesn't take a lot of removal of heat energy to lower their temperature. If you look at water in comparison, it's 4.18, so it takes a lot more energy to raise the temperature of water, just 1 degree Celsius. Why? Well, recall that water is a very polar molecule, and it exhibits hydrogen bonding, that strongest of those intermolecular forces of attraction. And so when heat is added to the water, it takes a lot more energy to move those particles due to those strong interactions between these molecules. And the specific heat value of water is on our reference table. It's on table B on the front and says specific heat capacity of water, which is 4.18 joules per gram Kelvin or gram degrees Celsius, depending on the question. So how do we calculate our heat? Well, the equation is located on table T. It says Q equals mc delta T, and it lists what each variable is. Q is our heat, m is our mass, C is the specific heat of the substance. Most likely is going to be water, which we now know is on table B, at 4.18. And then delta T is the change in temperature of the substance, and it's going to be the final temperature minus the initial temperature of the substance is our delta T. So let's see an example of this. How much heat is needed to raise the temperature of 500 grams of water by 15 degrees Celsius? So step 1, I'm going to list all the variables that I have from my Q equals mc delta T. So I see I have 500 grams, so that's my mass. The specific heat of water, because it says water, we know is 4.18 joules per gram degrees Celsius. I'm going to use Celsius because that's what's in the question here. And then we have a change in temperature. We're changing the temperature by 15 degrees Celsius, so our delta T overall is 15 degrees Celsius. So what we don't have is the heat. We're solving for how much heat, so we're solving for our Q. So now we're going to take these values and plug them into our equation, Q equals mc delta T, to determine our product. So Q equals mc delta T, our mass was 500 grams. Our specific heat C from table B was 4.18 joules per gram degrees Celsius, and our change in temperature was 15 degrees Celsius. You'll see that the units grams and Celsius cancel out, and we're left with joules, which is going to be our unit for Q, our heat. And then we simply just multiply 500 times 4.18 times 15, and we get an answer of 31,500 joules, and if you are rounding to proper significant figures, we'd round to 32,000 joules of heat energy is required to take 500 grams of water and increase the temperature by 15 degrees Celsius. Let's see another example. How many joules of heat are absorbed when 50 grams of water are heated from 30.2 degrees Celsius to 58.6 degrees Celsius? So let's first list our variables. We see that we have 50 grams, that's our mass. So mass is 50 grams. Our sample is going to be water, that's our specific heat. So we know from table B that's 4.18 joules per gram degrees Celsius. And we have a change in temperature here, which is going to be 28.4 degrees Celsius. So 58.6 minus 30.2 is 28.4. And now we're going to plug into our equation, Q equals mc delta T. We're going to solve for how many joules, so we're solving for Q, our heat. So we have our mass, which is 50 grams, the specific heat, the 4.18, and we have the change in temperature of 28.4. We multiply all three of these together, and we get an answer of 5,935.6 joules. And if you're rounding to proper significant figures, we round to 5,940 joules of heat energy is required to take this 50 grams of water and raise it from 30.2 degrees Celsius to 58.6 degrees Celsius. And let's look at one more example. When 418 joules of heat energy are added to 10 grams of water at 20 degrees Celsius, what will the final temperature of the water be? So just as before, I'm going to list my variables, and it says when 418 joules of heat energy are added. So that means we actually have Q, we have our heat. So Q is 418 joules. Next thing we have is 10 grams, our mass. It says water, so we have specific heat from table B, which is 4.18 joules per gram degrees Celsius. What we don't have is the change in temperature. It says that we're adding heat energy to water starting at 20 degrees Celsius. We want to know where does it end up. So we first need to solve for our delta T, our change in temperature. That's our variable. So we're going to plug into our equation Q equals mc delta T. We have our joules here, which is 418 joules. We have our mass. We have our specific heat. We're solving for a delta T. And so to isolate delta T by itself, we take the 418 and divide it by the product of 10 times 4.18. And we get a delta T, a change in temperature of 10 degrees Celsius. So when we add 418 joules of heat energy to 10 grams of water, it changes 10 degrees Celsius. Since we're adding heat, it's going to increase the temperature by 10 degrees Celsius. So then we say, okay, where do we start? Our initial temperature was 20 Celsius. We changed by 10. We added heat, so it increased by 10 degrees Celsius. So we're going to add 10 degrees Celsius to our initial temperature. And so our final temperature, which is what we are looking for, says what is the final temperature, is going to be 30 degrees Celsius. Let's check your understanding. Can you calculate heat, specific heat, mass, and change in temperature of a reaction? At this point, you should be able to calculate heat, specific heat, mass, and change in temperature of a reaction.